Good morning, dear students. I welcome you for the chemistry class. In this video, you'll be learning about simple distillation, fractional distillation, and crystallization method. First, let us study about simple distillation. There's a method which is used to separate a mixture of a solid in a liquid or liquid in a liquid. So that liquid is miscible liquids. It's a process of heating the liquid to form vapors and then cooling the vapors to get back liquid. It is used for separation of components of a mixture containing two miscible liquids that boil without decomposition and they have sufficient difference in their boiling point. So the difference in the boiling point should be more than 25 degrees. Coming to principle of distillation. The volatile liquid evaporates on heating, which can be recovered by cooling its vapors by the process of condensation. So this is the distillation setup. So you have a distillation flask and a condenser. So you have a beaker and a thermometer and you have a burette stand, tripod stand with a burner. So a mixture has been taken like acetone and water. Acetone boils at 56 degrees and water boils at 100 degrees. So now the difference in the boiling point, it should be more than 25 degrees. So what happens when you heat this mixture? So first the temperature raises. So when it reaches to 56 degrees, you can see all the acetone vaporizes and those vapors will move to the condenser. So they cools down and they start, they get collected in a beaker which is being kept down below the condenser. So the temperature will remain until all the acetone vaporizes and is being collected. Okay, now you will be separating, like you have separated acetone, it's been collected in a beaker, water is left in the distillation flask. If you want to collect the water again, you have to increase the temperature. So again, increase the temperature, what happens? So when it reaches to 100 degrees, all the water will vaporizes, so it moves to the condenser and it can be collected in a separate beaker. This is how you separate a mixture, acetone and water. The other application is it is used to remove salt from seawater to obtain drinking water. So when you take the seawater, when you just boil at different temperatures, you can see the things, the vapors will be collected and the remaining content in the distillation flask will be this salt. So this is one more application of distillation. So thing is where you can separate two miscible liquids which is having a boiling point difference more than 25 and you can also remove a solid from liquid. The next separation technique is fractional distillation. It's a process of separating two or more miscible liquids by distillation, the distillate being collected in fractions due to the difference in their boiling point. The process of obtaining a different gases from the air. So we know that air is a homogeneous mixture and it can be separated to its components by means of fractional distillation. So we'll study the application later. First we'll study about the principle and the procedure. So the fractionating column. So this is how the apparatus look like. It's very much similar to simple distillation, but only difference what you see is fractionating column. Yes, the apparatus which is used in the process is very much simple, very much similar to simple distillation, except fractionating column. Yes, which has been fitted in between the distillation flask and the condenser. The simple fractionating column, it's a tube which is packed with the glass beads. So what you see over here, it's a glass beads. So these glass beads will increase the surface area for the vapors to cool and condense repeatedly. Coming to principle of fractional distillation. In a mixture of two or more miscible liquids, the separation of various liquids depends on their boiling point. The liquid having lower boiling point boils first, and it can be obtained first from the fractionating column than the liquid which is having the higher boiling point. So as the flow chart for you. So air is a homogeneous mixture. So first we have to filter air to remove the dust and we have to remove carbon dioxide and water. So if you don't remove carbon dioxide and water, it can block the pipes. So when you cool the air, what happens? It can block the pipes. So because to avoid that, you have to remove carbon dioxide and water. Then air is compressed and cooled by increasing pressure and decreasing temperature. By repeating this process many times, So it will be converted to liquid state. So what we get is liquid air. And this is allowed to warm up slowly in the fractional distillation column. So gases get separated at different heights with their difference in their boiling point. So nitrogen has a boiling point around minus 196, argon minus 186, oxygen minus 183. So this is how we can separate different components of air. So you can see this in the diagram. Coming to applications of fractional distillation. It is used to separate a mixture of miscible liquids like alcohol and water. It is used to separate the crude oil, petroleum, which is used for many fractions like petrol, diesel, kerosene can be separated. It is used to separate different gases by the air by taking the liquid air. The next process is crystallization. So what is crystallization? It's a process which is used to separate a pure solid in the form of crystals. So from the solution. The process involves cooling a hot concentrated solution of a substance to obtain crystals. The crystals which is obtained will have a proper geometrical shape. They look so alike. So what we get in the form of crystal. So this process is known as crystallization. Coming to its applications. So purification of common salt which is obtained from seawater, to obtain crystals of alum from impure samples, to obtain pure copper sulfate from an impure sample. So this is a procedure. So how to conduct a crystallization process. So you have to take 5 grams the copper sulfate, the impure thing. So dissolve in water. So make a solution and then you have to evaporate. Evaporate so that all water content will be evaporated so that the copper sulfate solution will become more concentrated. So once it is done, you can filter it. So after filtering, so you have to leave it for a few hours so that you can just place the filter paper on that and leave it for a few hours so that you can get a crystals of copper sulfate. So whatever we get copper sulfate from this method will be pure because we are going with evaporation process and filtration process. So many minute impure things can be separated by filtration. So evaporation we are making a saturated thing. So no more impurities will be present when we do the method of crystallization process. So thank you students. So we'll discuss about the next things in the online class. Until then, have a nice day.